Hey everybody, this is Larry. This is not your average outline. Anyway, it's me doing the virtual contest weekly contest 464. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest and everything in between. I'm trying to find my pencil, got my notepad. But maybe I put it away. Hope everyone's having a good weekend. Hope that this contest isn't as sloppy as last week's, but we'll go. And hoping for an interesting one without them just throwing some random trivia-y things at us. Alright, let's go. Go. 1, 2, some odd and then okay. First n odd numbers. Oh. And what's n? N is 1,000. Okay, well, oh, odd. Okay, yeah. Man, this should be a 10-second problem, but I'm messing it up. Okay, fine. So it's going to be I times 2 plus 1, right? Does it even count? No. Okay, so then is alright. Let's just print it. Adding a print just so that I could check real quick. 16, 20, 25, 30 should be okay then, right? You could, of course, there's a formula, but why waste time on a formula? For contests, we could do that later. All right, partition array in the k distinct groups. Nums k, all elements of nums in the one or more groups such that there are k distinct. Each group has k distinct elements. Each element true. Okay. Each element in none. Okay, yeah. Each group contains exactly k distinct elements. So what does dupes mean in this case? I mean, you have this, but then there's also the case where if you have just an extra number, then it could be 2, 2, and then whatever, right? So what does this mean? What does this mean? And n is pretty big. K is pretty big. Nothing crazy. What does this mean? That's what this question is about, right? The implementation is probably pretty straightforward. What does this mean? Do we sort? How do we treat the dupes? I mean, that's the problem that I'm trying to figure out. Because then, yeah, here, for example, if you do a set, there's 3 distinct ones, but 4 numbers, right? Is it just greedy? Well, maybe. I mean, with this much, I mean, it is, but you have to do it in a smarter way. I think greedy is fine, but yeah, and you have to be a little bit smart about a greedy because you can't just go like 3, 5, and then you're stuck with 2, 2, and then you can't really have unique things, right? Oh, I guess the key thing is just that for distinct numbers, we. I guess, is it a min-max problem? Why am I so bad at this? This feels like for a Q2 I should have a more intuition about it. Am I looking for true or false? Maybe I'm looking for false. False, because I was looking for a true result, and trying to find the exact group, but maybe we can just find a false result. What is an impossible result? What does distinct number of elements give us? Okay, so if set of length of set of nums with length of this mod k is equal to 0, then we're good, right? If n mod k is equal to 0, I guess that's not technically true because they could all just have all the same number, for example, and then But this will be true. So then now, I don't know. What makes it false then? Do I come back to this one? Okay, what is the answer if k is equal to 1? If k is equal to 1, then it is basically just this and that's it. What if the answer is 2? 2? Two is either this or I don't know. I don't know this one. This feels like a maybe there's a very simple solution, but I don't know that I have an idea about it. Because you have to figure out. Do you try for the number of groups? Binary search of the number of groups, maybe? How would that work? I don't know. I feel like this one's tricky. Let me skip it a little bit. Maybe I'll come back to it. Maybe it's not that bad and I just can't figure it out. So the number of accepted is way lower on Q2A. So okay, maybe not. Maybe because so many people get accepted. I'm cheating a little bit, but sorting doesn't do anything. The elements don't do anything. Relation to the number sorting. It feels like a binary search in the number of groups, but that doesn't feel right. So, okay, so one group is no good, two groups is good, three group is no good, right? So how would that work? I think that works that way. Do we try every possible group? Is there like a sliding thing? One group is all of them, two group, and then three groups, how would you even break it up? I mean, it's not possible, so. Oh. I think I'm missing something very obvious. Do I draw it out? Huh. I mean, it's all about the distinct number, the things. So what does that mean? And is it, do we have a function on the number of things? Okay, so the number of unique things, does that set the number of groups? Not necessarily. Huh, why am I so bad today? Huh. Wasting too much time on Q2. I don't have time for the other ones, but and we don't always want to split them either, so that's the tricky part, right? Did I misread this one? Each group exactly k distinct. I mean, that's it. No, I don't think I misread it, but I'm not getting it. I'm not seeing it at all. Because we can also have, if you have another number, then the distinct doesn't matter, right? Which is what this does. How do you say this is good though? This feels like one of those forms where I could get it, but it would take like 5 wrong answers. But is there a pigeonhole? Maybe there is a pigeonhole. Because we want K distinctive. So that means that, what does K distinctive mean? It's probably a pigeonhole, okay. Because if we have enough 2's, then we can always do it. Right, for example, like if K is equal to 3, no, I mean, well, K equals to 2, then we have enough 2's, but if K is equal to 3, what does that mean for this one? Well, this means that by default it just happens, but what if K is equal to 4, then no, then, I mean, yeah, I mean, it's definitely forced that, that if length of f is less than k, and just return false. But then how do you get this one? What is the rule for this? If we have enough, if we have 2 extra numbers, would that be good enough? I mean, yes, but, well, no, not always, right? Because you could have 1, 5, 2, 2, 3, 3, or 2, 2. Then in this case, there's still no way, right? Because of the pigeonhole, because because by that pigeonhole, 2 of the 2's have to be in the same one. I think I do a for loop on the groups, but I'm not quite sure how to do it. Yeah, I don't know how to do it. I may have to come back. Maybe I have fresh pairs of eyes. Okay, how long did I take there? That took 10 minutes. I don't get that problem. I don't know. All right. Nums I, jump to another index j. Okay. Jump to j if j is, I don't know why they will I is less than j, but okay. If, okay, so, I don't, this is so confusing. Okay, so I goes to j if num sub j is smaller. Okay, or goes to the right maybe, right? Okay, so that's for me just easier visualizing. Goes to the left if num sub j is bigger, is it? Yeah, right. Okay, so you can jump. Okay, fine. For each index I, find the maximum value nums that can be reached following any sequence of jumps starting at I. Okay. Okay, so you have big numbers. You want to be able to jump. from everywhere. This is what you call it. I mean, this is there's a union find E thing here, right? Yeah, because then you could jump, because you could jump to the right, you jump to the left, and you could go back to the right. So it's a free move. Maximum. Okay, so it's a union find. Well, yeah, but you can do it with union find, but you have to, or it's the same idea with connected components, but I don't know if union find is the way to do it, or being able to do it without being n square. I guess maybe that's fine actually. How would you even, is it union find? Maybe that's not quite the right way to say it, because for example you have like 1 5 or let's just say 4 5 2, then 2 can go to both of these, right? But it's not a union find per se, because you can't go from 4 to 5. Okay, so what am I saying here? I mean, it is some sort of DP. I have to figure out what that means. Man, today is just a rough day. Like I have no idea. And it's just about going to the max value. Can I go backwards? Right. And then just, if we go backwards, then we just calculate them all at the same time. Okay, that seems reasonable. Okay, so then what happens if you go backwards? That means that, okay, if we go backwards, then you can go backwards to the right if they are bigger. Is that right? They could come up to us if the number, so now it's smaller, right? Why is the symmetry the same? Kind of confused actually. It goes to the, so going from the, I guess we said, okay, no, I think the symmetry is right. It's just a little bit awkward, or in my mind it's a little bit weird. So then we start at, it's like a shortest path or longest, it's not shortest. Can you do it that way then? You start with the biggest number, then what does that mean? That means that everything to the right, which is smaller, we can reach, and that they can reach to us. Right? Yeah, and then we don't have to do anything more. And then that means that, well, if you're the biggest number, then everything to the right is already smaller. And then now we find the second biggest number, and then everything to the right of that. Okay. So then we just have to figure out, well, no, that's okay. I mean, that's true, but that's only one side, right? On the left side, everything bigger to the left, we also mark as, no, if they're bigger, then you don't, by definition, you haven't calculated them yet. So everything to the right, smaller, set. The set. Is that true? No, not, I mean, yes, but not exactly, because here you could go from 2 to 1 to 3. So not quite. Where here, yeah, okay, so let's see. So let's start again. So biggest number, everything to the right, or to set to that number. And then now, starting from that number to the left, okay, what? He wants to be able to the right, maybe. Well, if it can't go any number to the right, like if it's the smallest number, then it's the biggest number to the left. right? Is that right? Biggest number to the left, and then keep going, and then just a for loop. Maybe? Definitely feels awkward though. Huh. No. I mean, yes, but this, if it goes to the second biggest number, that, because you can go, so the smallest number can go left to the bigger number, and then it goes right? And then it goes left. So, what is general rule? Okay, so biggest number, and then just slowly go down. So sort by that and then process. Is that sufficient? I don't know. Let's give it a try. I don't know. Right? I don't know. Reps. No. Well, I mean, yes, but index first, right? So right? No, we want max first. So yeah, and I think tiebreakers don't matter anyway, so I think that's fine. Okay, so then now, what do we say? We'll say every number to the right of it will get set to that number. Then the next biggest number, I mean, that's fine. Maybe. Yeah, because every number, okay, I think it's fine. It's just, it feels awkward, but I think the amortization is fine. Okay, what am I doing? Okay, I think the amortization is very awkward actually, but it should be fine. Okay, so X is the biggest number we've seen so far, and then now we go everything to as long as you make sure that's awkward. We have to it doesn't okay, so we set something to done, but yeah, okay, so answers of X or index is equal to X just because right now it's the biggest number, but then now by definition all the numbers we've seen, okay, so maybe no, I mean you can, but not specifically like that, right? How would I write it? I think the idea is right, but I don't, but maybe it's not quite precise enough. the queries. It's a monotonically increasing thing. Oh no, I mean yes, but also no. I mean yes, but also there's the thing about going back, that's why. Okay, I mean I get it, I think. Maybe I don't do this quite like this yet. Maybe we do a sweep. So as a prefix max almost. Okay, so then that gives me all the everything to the right thing. And then the question is then can you go to the right to go to the left? And that's a query we have to figure out how to enter smart most thing. How do we go through those? Binary search. Yeah, okay, this is like an LIS actually, right? Then now, yeah, let's say if x is not equal to mx, then that means that it went to the, it is an answer from the left. Then we want to, if x is not equal to mx, then we want to keep the smallest, right? So something like that. I guess this is fine too, really, right? Is it key? Lambda. Blanking out today. Oh no. Okay. So then let's put it out real quick. I think this gives me the answer I kind of want. So 2, the smallest is going to be 1, 3. So then now, this is going to be what does this mean? I mean, we need to do a prefix backwards, right? Because it means that if you're 2, then you could go to a 1 later, right? So we have to do a prefix backwards, right? So maybe for key value in f.items, we want to sort by the key. Right. Oops, the other way around. And then I want to write this, but I think that actually oh, I mean, I think it does, but I think I just have to convert it to a list. Is equal to value. think that's fine. Let's run it. Okay, don't give me a concurrency thing. Did I mess up F? Oh no, I got smallest. Why did I? I think F is the frequency. Lazy. Oh, whoops. Okay, and this is Did I not do this right? Oh, Dumbo. Okay, so then now we go over it again, right? Now, does this help? Well, okay, now we have this, and we want to be able to binary search on the keys, right? Guess that's the thing. Because then for each number, we want a reverse thing. Any number. Because then now every number with a 1 gives you a 3. In this case, it's every number. Does that look like for here? So then now 1 gives you a 2, and then 3 gives you a 3. So then you binary search on the thing, and that should be fine. Okay. So then now we have we want to say let's do this again. Just throw it out. Because technically you don't do it in reverse anymore. And now we just have a binary search of yeah. I need to be a little bit cleaner on the 1, 2, 1, 3. I mean, maybe I don't write it this way. Maybe I write it in the based on the value, right? Maybe I have some, I don't know, just call it F now for now, whatever. Right. And then now this means that F of n is equal to basically max of F of mn, or the key. Yeah, okay. And now we have that. It's a tricky one. I'm going very slowly, but I don't even know Q2. That was kind of bad. Okay, so yeah, this is what we want. And then now we can just go by, yeah, okay. So then now for KV and after items, we just put it in a sorted list. I mean, I don't actually even have to put in a sorted list because we can just sort it once in a binary search. I'm still going to call it sorted list. We want to put it in a key value. I think that's fine, maybe. I think that should be fine. And then now for I range of n, yeah. Okay, then now we binary search SL on this being the key value, and then they should always give something. So then now SL of index of element 1 is the answer, right? Something like that? Yeah, this is a very hard problem, or just annoying for me. Okay, maybe I was wrong. Did I get this one wrong? Why? Oh, I forgot to sort it again. I mean, I think this is reversed, but either way, I think this is fine. Still wrong though, huh? I did know. I did try to remember to sort it, but I just forgot. 1, 3. So that's wrong. Huh? I did have like different things. Am I looking at the wrong one? Oh, I guess this is. It's only one for. I don't like that they jump around the problems or the test cases. Okay, so this is right, but it is binary searching for. Oh, huh. I did it. I mean, this is kind of right, but I think I did it in the wrong way. So actually, we want this, and then index -1, I suppose. This stuff like this always makes it's a little bit awkward. Yeah. This is wrong though. The 2. Search to 2. Why do you find? How do you even get to 2? Like how? Oh, I will index instead of I. Alright, that is just pretty bad. But I mean, yeah. YOLO submit. Hopefully, nothing too silly. Ah. Is it a misunderstanding or a thing? Expected is 11. Oh, it has to be strictly smaller. Okay, I mean that's a easy fix if I could figure it out. That's actually that changes it a little bit. I have to think about it. That is actually a little bit messy, because then now I can just say every 11 or higher goes to 18, because in this case that's not true, right? Okay. I might have to. This is. I'm very annoyed because that's actually not a small change. Maybe I'm wrong. I made some assumption there. I mean, I think this part is still right, or this part anyway. 11 has to find a number smaller, but I try to simplify it a little bit too much, I suppose. Okay, definitely not. It is just. So then, yeah, I mean, I think this is fine, honestly. We just have to go backwards. And then binary search again, but it's a little bit weird, right? I mean, it's not even gonna have time for Q4. This is a disaster. What is F at this point again? I forget. F at this point is 11 saying 18. Okay, so that's. Oh, this is the going backwards part. And 18's min is 11. I get a water. I guess maybe I could have done it with segment tree, honestly. Maybe that is the way to do it. Because it's just updates and mins and stuff like that, but that's really like, okay, I don't have time, so let me look at my segment tree stuff. What do I want? I want range update and also range min. Alright, I don't know where I got this from, so maybe it doesn't work, that'll be funny. Okay. Which version is this? Oh, this is the derivative version actually, so that's kind of cool. Alright, no it's not. But, alright. No, do you want the min? No, you don't want the min. I mean, you want the min. It would be nice to have the min, but what you actually want is some sort of mono stack, right? Because you want. No, you want the min. No, do you want the min? No. Do you want the min? Maybe it's not segment tree. Today is just a struggle. We're so close. Okay, go backwards. What are we doing? All the numbers were upgraded. Okay, we're fine. And then now, question is, for every number inside those chunks, can you upgrade? I think what I was doing is so almost right that is frustrating actually. That's why I'm like trying to, maybe I'm just stuck a little bit in my head as a result. This is a little bit off as a result. I could just subtract everything but what I want. That would be funky. Jeez, I'm 45 minutes in and I got one problem. This is maybe one of my worst contests ever, but okay. Okay, so for every number inside those intervals, we want to know no, I mean I think this is fine. We just have to know so for a number outside of it, we just need to do a +1 maybe? I have to just incorporate these two together, I think. In a way. Maybe I just need to do a +1 somewhere. And this maybe has done backwards. This, I mean, this probably works, but I have to do it in another way. The smallest array as well is the smallest of max, right? But But if you're jumping into it, and also you can do multiple jumps, Larry. So it's not even quite true that you can just do a +1. Oh. Huh, I am dumb. You can jump to. So actually, no, I got this all wrong. In this case, you can't though, but and it's wrong for a different reason, but I'm wrong for another reason. Because then, no, I think I collapsed this, right? Because that's what the collapsing does. Maybe I'm just confusing myself now. So basically, given this number, we look at the max. Okay, so every number, let's step back. So every number we want to make it go to the max on the left side. Okay. And then we just collapse adjacent numbers. Because in this case, 11 is the max, that's why. It's not that I did the even thing. I mean, that's a little bit off, but 11 is the max. So then we want, so we have to go back to here, right? Yeah, I mean, I always submitted, I can get it back. But, okay, so we have this, and then now, that means that okay, I think I get it now, maybe. I mean, I think I just need to also not do it this way, which is if x is greater than mx, then mx is equal to x, but we'll also maybe start a new region, right? Maybe off region and index, right? Right? Current is equal to index, maybe, and then r of current, and this is the min thing actually. So maybe this is, maybe I'm doing the same thing in a different way. Okay. Okay, so you have region. Okay, but now we're doing it by index, right? Yeah. Okay, so then now we have the region min, and then now we go backwards maybe. I don't know if this makes sense. But yeah, and because then now we can go backwards. Maybe AR to be more precise, because then AR of J is the thing, and then we want to see if it collapses into the previous one, right? So that means that if the min element of this, okay, fine, the regions So okay, let's just call it index is equal to this, and then all of the this is smallest number. So if this smallest number is smaller than the biggest number in the next region, so I have to do this backwards actually, but j minus 1, then if this is the case, then we just merge, right? Then that means that AR of we could just we could dedupe later, but we could just set that as equal to index. If it's greater than that, then now I store this in a weird way. It's not current anymore, so that should be just index. Yeah. Yeah, maybe I could win this better. But I think that's mostly how. And then if on a merge, my head is just not thinking today. On a merge, okay, so you merge and that's fine. And I mean, we could do a linear loop. I think it's fine. It amortizes from range from that index all the way to this index. Right. Equals something like this. Though this is wrong, but no, this is right. I wrote this in a really weird way, so I might just be messy. I don't even return an answer. And also this is answer. 2, 3, 3. I mean, this is wrong, so that's no good. But do we merge? Nope. What am I printing? So what are my maxes? Maxes on 0 and 1, that's right. So what is AR? AR is the index, so that doesn't even make sense. We need the all of this. Merge, okay, so merge is okay, but it is not actually merging, which is not as okay. It's because we update this before we update the merge, so we need the old index. Okay, okay, okay. Is it good? I don't know. I might get like 5 wrong answers, but we have 36 minutes left, so I'm not even close to being done. And we are clearly not done. I mean, my idea is still like it should be able to handle this, but it doesn't clearly. So, I don't like the setup I have here, but it is what it is. Pre-index is go. I should have done this to begin with. No, this is this I need to. Okay, I mean we need to figure this out, but now we can maybe look at AR and maybe R. Right? We stop at 0 and 3, so that's right. 0 min is 5, that's right. 3 min is 24. All right. So we look back. Oh, this isn't right. That doesn't make sense. It's nums. We want the biggest number, right? So then now it merges. Yep. Okay. I don't know why. I think I got confused when I was changing it because the other one was definitely wrong. Maybe what I changed it to is slightly more right, but this is still wrong. Oh, 9 goes to 6, but okay. I mean, that makes sense. I mean, I am not testing as much because I am so far behind. But I think I should be able to handle this case other than a silly mistake. So 0, 1, 4, that's right. 0 is 9, 1 is 6, that's right. 4 is 9, that's right. We should merge. So I don't know, something's not merging quite right. There is a merge. We go to this doesn't seem to. Well, I mean, I guess we have to also min the other number. Maybe that's why. Merge, it goes 4, 4 to 4. Oh, 4 goes to 9, and then update the previous index instead. Okay, so that's why. I mean, I think we probably should do this anyway, but we should also just update this. I think maybe that fixes it. That is a little bit wonky, but I don't know. At this point, I'll take wonky and correct for now. I should double check all the other things, but okay. Ooh, 33 minutes left. 6-point problem. Let's look at Q2 again. I don't k-distinct. I don't know exactly k-distinct elements. It's very weird. Do they mean like k elements that are distinct? Maybe that's easier. What would that say? K elements that are distinct. If it's k elements that are distinct, then what does that look like? So meaning that there are no dupes in the same group. I wish they have a thing where they show it. Well, it's still true that. Well, if n mod k, I'm just going to YOLO guess on this actually. I mean, this is still true if you don't have. You know, otherwise, groups is equal to n divided by k, right? And then how do you separate them out? Yeah, I mean, okay, there is the other thing of just this. I think that's it though, right? Like if this is the case, then if max of f dot values is greater than groups, then we return false. Then otherwise you can just you don't need to construct it explicitly, right? Is that the thing? True. I forgot that I could turn this on to this thing. I should have done it for Q3. True. Okay. Wow, that is a really poor problem. Problem setting. That's like a very ambiguous problem. That's really bad, actually. Okay, so we have half an hour. Can I get this? How does the ranking look? If people got it, well, okay. I always forget that there are a lot of cheaters. No one I recognize on top, so that's not a good sign for me. I was hoping that someone got it really fast. That means that I could maybe do it slower, but still fast. We have half an hour now, so let's get started. Well, okay, so we have robots, distance war, right? Robots I position, okay. What does that mean? Okay, straight line, so 1D axis. Distance of I is the maximum distance I. But what? Where does the bullet come from? They just dropped that here. Anyway, yeah, maybe you should you know, talk about this part first. Each robot has a bullet or something. Okay. Anyway, robot can shoot a bullet and there's a wall. Okay, every bullet can one bullet. They can fire to left or right at most distance of I meters. Okay, I mean, I guess that's what this part is saying. Though they wrote in a really weird order. A bullet destroys every wall in its path, and like, okay. Robots have fixed obstacles. If a bullet hits another, it immediately stops at that. Robot cannot continue. Okay, so you could destroy walls, but not robots. Okay, a very weird bullet, but anywho, maximum number of unique walls. Okay, so it's almost like some sort of I don't know, whatchamacallit, like I don't even know anymore. I think it's DP though, probably, because just DP on right is left or right on the left. Because you can't shoot past a robot, so well, okay, so what does unique walls mean? Does each robot get to shoot once? Oh, has one bullet. Okay. Okay, so we was here. So we have a robot at 4, and it's just maths, right? Binary search, maths. I assume walls are sorted, but maybe I just sorted anyway. I don't know. I mean, actually, maybe you can assume that, even though that is really silly. But robots sorted. I guess robots are also maybe not sorted, so let's just sort it. They are unique though. Okay, so then yeah, I mean, I don't know. Right? I mean, I think there's just DP, right? I don't get it. DP, maybe binary search. I mean, maybe both is what I mean. There are really only 2 states, whether the pass robot shot or not, right? If it's shot to your direction, then whatever, right? I don't know, shouldn't be that bad, maybe. I don't know. But I feel like if it wasn't that bad, then more smarty pants would have gotten it. Still trying to find someone I know, but not finding someone I know, it's a little bit awkward. TS Reaper took 20 minutes. That's not a good sign for me. If it's someone that smart took 20 minutes and I only have 20 minutes left. 27 minutes. Okay, but we have index robot. We have to maybe how do they shoot or not? We can also just say I don't know, left side as in the walls that they destroyed, and unless I'm misunderstanding this form a little bit. And then that's it, right? And the left is, I mean, left is a big number, but it actually is just 2. Is whether it just controls whether the robot, the previous robot is shot or not, because it doesn't extend, right? So index is equal to n, then we just return 0. Otherwise, then yeah. Okay, so now we have, and we always want to shoot, so shoot to the left, shoot to the right. So this is not quite a take no take fit, best equals 0. We already sorted wars, so we want to shoot wars from robots of index to robots of index minus distance of index, I suppose, right? That's I have to mess this up. because I because I sorted robots, but I have to yikes. Rx and then our distance, insert robots distance, right? Something like that, nothing too bad, right? And then now we want to, I mean that's fine. It's gonna be n log n. It's just a lot of binary search. To write that, that's fine, easy to write. So, robots minus distance, so shooting left, so you either go to left boundary, is you go to either the left boundary or robots, right? Pretty straightforward. And then now it is going to go index +1 left. No, the left boundary is now at robots R of index plus of 0 plus 1 because you don't want to shoot the robot. I mean, there's no wars at the robot, right? I guess that's not actually clear. No, there's a war at the robot. How do you even? How does that work? This is a very poor farm. Why would you put wars and robot at the same place? What does that even mean? Like, can you say if it goes left and right? It's very weird. But in any case, it should be fine because this robot will get it. So then we'll just set to +1. And also I have to write R index of 0 minus R index of 1, right? And then this is this plus the number of rows. So that is just going to be the binary search. Do I want to save this? I mean, I think no. I mean, we could probably cache it, but it's not. I don't think it's a big deal. Bisect left of the rows from LB all the way to so this is and then bisect right was our index of 0. Right, so subtract this, that's the number of unique rows. I think we should be good for search. Right, okay. Return best, oops. And return go 0, robot sub, no, negative infinity. Alright, I mean, I know that this isn't done. We haven't shot to the right, but I just want to see if it gets things right. Can I access left B? Oh, yeah, of course. No. I mean, well, yes, this part. Okay, there you go. Okay, I mean, we only shoot left. What does that look like? 1, 3, and 0. Somehow that all the inputs are only shooting left. Thanks, Leetcode. You are useless. But anyway, okay. So then otherwise shooting to the right, we just skip to the 1. The new left is going to be, so we shoot to the right, then we have everything inclusive of so we want to +1 it so that it doesn't double count it, plus. And then now we can bisect. We want to go from this to bisect left of rows of index of 0, and I think we should be good. Hopefully 1 3 1. Okay, well, shooting right apparently made this no Gucci. Oh, okay. I have to. Okay, I didn't do the. I was like, that's a bad wrong answer, but I forgot that it cannot shoot past the robot. That's actually pretty good because then yeah. Oh, that's a pretty good example because I actually forgot. Okay, so then left boundary in this case is equal to also if index is greater than 0, then it cannot go past the robot to the left, which is going to be R of index of index of -1, the position, right? So yeah, okay. Is it +1? I guess it doesn't matter if it's no, we should make it +1 because you don't want to shoot past at the robot because I think the left actually takes care of it, so you cannot shoot past on the left side anyway. Okay, I don't think we need this because that's what the left side is for. The right side we don't take account, and our assumption is that okay, fine, right boundary is equal to f min of this number, or I guess it's just this number first, and then if index +1 is less than n, then might be f min of r index +1, the location. Right? Not inclusive, so we have to be careful. That's what I'm trying to think. Okay, I think that's right. Then now this is just, yeah. Maybe, hopefully. Oh, I forgot to do the f min. If it looks good, I'm YOLOing. We have 18 minutes left, so we don't have much time to kind of think about it. Yeah, okay. That's a little bit sad, honestly. Because I was hoping, but the fact that we shot more rows than expected means that actually maybe our logic is still right, but there's an implementation error. And it's probably on the right side, I wouldn't say, but maybe not. Maybe I haven't given much thought on the left side. Left side should always index +1, right B. No, this should be always be at least, even if this is 0, should be okay. So that should be set correctly. And because the only interaction is in between, so there shouldn't be any more states. Left side, we want to be inclusive if we can. Yeah, no, left is always +1, so we always keep track of that. Is it though? We shoot to the right. Oh, why is this a +1? I think +1 is what okay, so maybe that's why. Okay, that would be good if that's true. That's how much we shoot, but the boundary is +1. I think that's the thing. Okay. Yeah, maybe. Let's see. Alright, I mean, it fits for this one, so maybe I did actually just copy and paste it wrong, for sure. Okay. I mean, we actually did this one faster than some. Oh, Alex actually did it. I mean, Alex is Alex. I don't. But if I had seen him, but yeah, I mean, we did actually did that one relatively fast. We actually had a legitimate. I can't even English right now. We had a real silly issue, but and Q2 was just dumb, right? Like I spent so long on this one, and I was just kind of like, I think maybe they meant it this way because otherwise I don't know how to solve it still. Like it may have even been NP to be honest, but I don't. And this is where if you had like a stronger knowledge, you could have been like, oh, this is clearly NP, and then just know that that's not the way to do it. But yeah, I don't know. Yeah, I mean, I'm surprised I finished, to be honest, because we did this one in 17 minutes Q4, and we saw like smart. Maybe I just missed some smart people. Ooh, Yui did in 6 minutes, which is not surprising given that I know what I know now. But I don't know why TS Reaper took so long then. That one's actually surprising to me. Not to call him out or anything, like, we have very ridiculously smart people. I took a while on Q3 as well. But they're definitely like a very weird contest. Especially since Q2 is a little compromised, if you ask me. They do not know English or something. I don't know. K distinct elements can be interpreted many ways, I think. Or maybe the 2 ways, and the other way is a little bit more common. And the examples are kind of they don't tell you the story, right? This one this one I had 3 wrong answers, but 2 of them were just like I had the idea right. This one, no, that was the wrong one. And then after that, I had the right idea, but implementation was a little bit wonky. I updated the wrong thing. I don't know. I mean, that's just silly. Like I should have gotten that one without about so many wrong answers, but yeah, and I had a it wasn't a typo. It was copy and paste, I suppose. I don't know if you yeah, I don't know, because I copy and paste this with +1 and I left it in. Silly mistake, but I don't know. Yeah. I don't know. I feel like that was an okay contest. I mean, I probably could have done a little bit better, but finished strong, surprisingly. Honestly, I didn't feel like I was starting strong at all. Q2 and 3 took basically an hour, right? But Q4 I actually did pretty quickly. I actually don't know why it 354. I don't know why not many people got Q4. I thought it was pretty fine. I thought the states were kind of obvious-ish, but not really. I don't know. I mean, it's not obvious, but I thought more people would have gotten it in either case. Anyway, though, that is all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.